Okay, so today we are going to talk about the problem of logic minimization. Previously we had discussed the Carnot map method for logic minimization. Today we will talk of an alternative method, and which is called the Quine-McCluskey method. There are a number of other logic minimization techniques that have evolved, but primarily they all revolve around a similar approach as Quine-McCluskey, and there is an evolution from that. So at the outset, let me point out what are the advantages of Quine-McCluskey over Carnot map, or what are the disadvantages. Carnot map is basically a graphical method. It's not very suitable for large number of variables. If you really look at it, we are trying to spot adjacencies. We are trying to arrange the minterms in a manner so that they only differ by 1 bit. The neighboring cells differ by 1 bit. But as the number of variables increases, after all, you can have only 4 neighbors if you are doing on a drawing on a sheet of paper, and whereas if the number of variables increases, the number of neighbors also increases, and spotting that becomes difficult. So it's not very suitable for large number of variables, and it's also because it's graphical, and it's basically you are trying to find whether the terms combine or not based on visually. It's not something which is very suitable for programming. Quine-McCluskey, on the other hand, is a method which doesn't suffer from these disadvantages. Though actually functionally what's going on is the same thing that's happening. That's basically you are trying to eliminate variables by looking at terms which can combine, but the way that it is done is different. So let's look at an example, and I will illustrate the Quine-McCluskey method using an example. So this is a 5 variable function. Y is a 5 variable function of a, b, c, d, e, and I have, these are the minterms. So this is a canonical representation. So 0, 6, 7, 8, 20, 22, 24, 26, 30, 31. So these minterms constitute the function. And now the first step that is involved in this Quine-McCluskey method is you classify the minterms according to the number of ones that are present in the minterm. What it means is, if I consider them to be an integer and expand it in as a do its binary expansion. So for example 7, because there are 5 variables, 7 would correspond to 0, 0. So 7 would be like 0, 0, 1, 1, 1. And there are 3 ones that are present over here. So I am classifying this. So number of ones can vary from 0 to 5. 0 has no ones, and 31 can have 5 ones. So the number of ones will vary from 0 to 5, and all the minterms will be classified depending upon the number of ones. So 0, 8 has only 1, 1. 6, 20, 24 has 2 ones. 6 consists of 4 plus 2, this consists of 16 plus 4, this consists of 16 plus 8. Sorry. And there are 7, 22, 26, there are 3 ones, and so on. Now we have the basic conditions for combining minterms, and let's understand this. So it's important to realize that under what conditions 2 minterms can combine. 2 minterms can be combined to form an implicant. We are calling them to be implicants. That is, these are the product terms or cubes which do not have all the literals present, all the variables present in true or complement. So those are, we are referring to them as implicants, but primarily they are equivalent to the product terms. So only can be combined only if and only if the integer values of the 2 minterms differ by 2 raised power k for some k greater than or equal to 1. That is, the 2 integer values for the minterms differ by some power of 2. So it could be, they could differ by 2 or 4 or 8 or 16 and so on. That is one condition. The second, the minterm with a larger integer value has more ones than the minterm with a smaller integer value. If you look at its binary expansion, and if you look at the number of ones. Primarily what we are saying with this is, if you consider the 2 minterms, one of the variables have to be present in a complement form in one minterm and true form in the other minterm. If you consider any variable which is present in a complement form in one minterm and true form in the other minterm, this condition will be satisfied, because it will have a weight of, so this particular variable has some weight, okay, depending upon the number of variables. So it has a weight corresponding to 2 raised per I in the integer equivalent, and that 2 raised per I, that's going to be 0 here for the complement version, and for the true version it has a weight of 2 raised per I. So the two min terms are going to differ by 2 raised power I. So this is the let us say condition that is required for combining min terms. So once I do that, once I understand this, then I can do the generation of implicants. So I already classified this min terms in terms of number of ones, 0, 0, 1, 2, 3, 4, 5. In each stage of this process, only the min terms from the next level can combine. That is, 1 with 0 ones can combine with the min term with 1, 1. And I will what do I have to do is, I have to take a min term from here. 0 can combine with 8 because 8 has more number of ones, one more 1 than 0 has, and the difference is 2 raised power I. In this case the difference is 2 raised power 3. So I can write this over here 0, 8. Now I consider the min term here with the min terms in this. So now in this case what happens is, if you consider combination of 8 and 6, it satisfies only the first condition, that is the difference is 2, so which is 2 raised power 1. But it does not satisfy the second condition, because the second condition was the min term with the larger value should have more ones. So here the min term with the larger value is 8, and it has one less min term than less 1 than 6. So 8 and 6 cannot combine because it does not satisfy the two conditions, it only satisfies one of the conditions. If you consider 8 and 20, the first condition is not satisfied, difference is 12. But if you consider 8 and 24, so it is, the difference is 16, and so it satisfies the condition, and so it is 8 and 24. Now let us look at this. In this case I have to look pairwise, 6, 7, 622, 626. So if I look at 6 and 7, the difference is 1, and it's a type 2 raised power 0, so this will be satisfied. 6. Oh no, okay, no, it should be k greater than or equal to 0. That's my mistake. The value 2 raised power, this one should be greater than 2 raised power k value should be greater than or equal to 1, not the k itself. Okay, that was my mistake. So 6, 7 is will combine. So you can see that 6, 7 will combine just looking at, in this case. So this particular variable will be eliminated. If you look at from the Carnot map, so they are actually neighbors, because they are only differ in the variable which is, so A, B, C, D, E. So this is A, B, C, D, E. So this is E complement and this is E. 6 and 22, the difference is 16, they will also combine. 6 and 26 will not combine. 20 cannot obviously combine with 7, the value is more. 20 can combine with 22. (20) cannot combine with 26. 24 of course cannot combine with 7 and 22, but 24 will combine with 26. Okay, so this. So these are the combinations that are possible over here. So these what I am doing is I am generating all the implicants. Now let's look at this one. 7 and 30, okay, they won't. 22 and 30 will combine. Difference is 8, and this has 26 and 30 will also combine. Now if I compare this, 30 and 30. Now let's go to the next stage. The process that I did at this stage, from this particular row to this row, is exactly, I will repeat this, except that now when I am going to, now what I am doing is basically now combining product terms. I already eliminated one variable. Please remember, the variable that should have been eliminated should have been the same variable. I should have eliminated the same variable in both of them. And if I look at pairwise, let's say if this has to combine, of course this cannot combine because 0, 8 and 8, 24. So I am eliminating in this case the variable that's eliminated was B, and in this case the variable that was eliminated was A. So it will not be able to combine. So in each case, so when I can find out those two terms in which the same variable is eliminated, and the difference, if you look at difference pairwise, the difference would be the same, because now what we are saying is I am now trying to eliminate another variable in this stage. In this stage I eliminated one variable. In this stage I am trying to eliminate another variable. So if you look at the Karnaugh map equivalent, I am now trying to make a box of 4. Here I had tried to just combine 2 terms, and I am going to combine 4 terms. So I am going to make a box of 4, and similarly if I have more stages I will just make a box of 8 or 16 or whatever, if I get enough terms to do that. So 0, 8 and 824 cannot be. If I consider this 824, so there is a difference of 16, and here there is only this one, but again it does not satisfy the requirements. So I cannot combine 824 with any of these. If I consider this 6, 7, I cannot combine with this, the differences are not equal. 6, 22, again I cannot combine. 20, 22, of course this 22 is common, so it will not anyway work. 24, 26 will not combine again with this. Okay. So is there any? Okay, so now do we? So I have to consider each one. So the combination. So here there is again there is no possibility. So did I miss any terms? Okay, so let me repeat the second step. So basically I consider each one of these terms again with this. So again, so basically if I look at this particular product term, one variable has been eliminated. In each one of them one variable has been eliminated. So what I am now looking for is trying to eliminate second variable. If I have to eliminate the second variable, the requirement that will be there is exactly the same variable should have been eliminated in the first case. In both, if let us say this, in this case B has been eliminated, in this case A has been eliminated. So I cannot possibly combine this with this. So if any term has to combine, the same variable should have been. So if you, let's say, let me draw the Karnaugh map equivalent. So if let us say this has to, so what I have done is I have managed to do this, I have managed to do this. Now if these two have to be combined, so this, now what I am trying to looking for is trying to do this combination. To be able to do that, I should have eliminated the same variable in both of these product terms. Now if you look at the minterm value here and minterm value here, they will differ by some 2 raised power I, and these two will also differ by the same 2 raised power I. Then in this case I will be able to combine all these 4 of them together. So if I evaluate now in this case, so it doesn't work in the first case. Now in this case 8, of course if this number is smaller, then anyway it will not work. So both these numbers here has to be larger than this. The second condition, please remember that. So in this case the difference is 20 minus 8 is 12, so it will not work. 24 minus 8 is 16, but 26 minus 24 is only 2, and also this difference is only 2, so that will not work. So now let's look at each one with this. 6, 7. So 6, 7, the differences are, there is only 1, and here the difference is 8. This difference is 2, difference is 4, and so this again. Okay. So now let us look at 622 and this. The difference here is 16 and their difference is 8. So this cannot be, this 2 and this is 8. This is 2 and this is 8. So there again there is no possibility. So in none of these cases I have a possibility of combining these terms with this. If I look at this 22, and so the difference is 8 and difference is 1, and of course this difference is also not the same as this difference. So I have no possibility of doing any combinations over here. 824 and 622. So this has more number of ones than this. Okay, because I have eliminated. So you have to have larger. And first of all, this difference is 16. Okay, this difference is 16. But this will not work because 8. These numbers have to be larger than this. They have to contain more ones than that. The ones which are. So I have already eliminated. So I started with 2 ones. So what had happened over here is, if you look at them, what does 6, 7 mean? 6, 7 mean that 0, 0, 1, 1 dash. After combining 6 and 7, this term means 0, 0, 1, 1. So it has 2 ones over here. And this one has, if you consider this, what does 8 and 24 mean? 8 and 24 means I eliminated the variable dash 1, 0, 0, 0. So obviously you can see that the number of ones that need to be changed from here to here is much larger. Okay, so this will not be, one would not be able to combine them.
So why do we have the condition that the minterm with the larger integer value has more ones than the minterm with a smaller integer value?
Okay, let me explain this. See, what are we trying to do? What we are trying to do is combine a variable where x complement and these are all 0, 0, whatever it is, with another term which is 0, 0, x, 1, 1, 1. I am trying to combine these two terms. That's what I am trying to do. So now, if I consider the equivalent integer of this whatever is the value, weight of this, so this is going to be, so let's say weight of this is I, so it's 2 raised per I into 0. This is the sum that it will contribute to in the integer, and this will contribute 2 raised per I into 1, because this is present here and this is absent here. And now rest of this, whatever they contribute, they should contribute the same. Some may be 1, some may be 0. So if you now look at this equivalent integer value, so this integer value will be 2 raised per I more than this integer value. But the number of ones here will be larger than number of ones here by just 1. And that is, these are the two conditions that need to be met to be able to do this. Okay, now let us look at, once we have done this, what do we do next in terms of minimization. So these are called the implicants, and now as we cannot proceed now any further than this, so we would have to stop here because there is none of them which satisfies this condition. So now the next stage is what is called the covering stage. But before we do that, I will identify what are called prime implicants. Let me define what prime implicants are. These are all implicants. A prime implicant is one which is not fully contained in any other implicant. That is, there is no other implicant which contains all the minterms contained in this implicant. So even the minterm can be a prime implicant. All minterms are also implicants in a very general way. So now if you consider this, 0, 8. 0 is covered, 8 is covered by 0, 8. So I can, or I can cross this rather than ticking. Okay. So now I no longer have to bother about it. I will try to use 0, 8 rather than. Similarly, if I consider this 8, 24 is covered, 24 is covered by this, 20 is covered by this, 6 is covered by this, 7 is covered, 22 is covered, 26, 30, 31. Actually all of them are covered by at least one implicant. But it could have happened that some of these minterms do not combine with any of the other minterms present. They may be isolated. In that case, we would have to carry them to the next stage of covering. But now as I am not able to generate any other more combinations out of these, so I have to consider all of these to be prime implicants. But if I am able to combine these and generate some other implicants, then I can eliminate some of these from prime implicants. So now what I will do is I will now generate a cover table. A cover table is something which is going to contain all the prime implicants. Okay, so the notes where I looked at, I realized there is a mistake over here, so we have to modify that.
Say it's not visible. Say it's not visible.
It's not visible? Okay, so I will anyway write it out. So this
So we can use zooming.
okay. I need more than one sheet. Okay, so that's not a very nice thing over here. Seven, 8. No, sorry, this has to be repeated. I can't draw in 2 sheets. It will not work. So let me draw. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9.
You can make one. You can make on the board.
Okay, what it consists of is, it consists of columns. Each column corresponds to a prime implicant, and each row corresponds to a minterm. And we basically now say that whichever it's, let's say 08 covers these two, 824 covers these two, 6-7 covers these, 6-22 covers, 20-22 covers this, 24-26 covers this, 22-30 covers this, 26-30, 30-31 covers this. So this is called the cover table. What cover table contains is the information that which prime implicant covers which minterms. So I have a table consisting of, so now what do I have to do is, I have to choose some prime implicants to compose my function. First thing that you should understand is, let us say, I never have to choose those which have been eliminated. I don't have to choose this minterms, and it would be sufficient to choose only from the prime implicants. The reason is simple. Anytime I have to cover 0, I would be better off using the product term 0,8 rather than 0. Because 0,8 covers 0 and something else, and it has one less literal than 0 has, because I already eliminated. So the first thing that you should understand is a subset of prime implicants is sufficient for me to ensure that the function that is generated is minimal. A non-prime implicant will never contribute to a minimal function, in the sense that minimality is defined as reducing the number of literals. So my objective is only to choose from a set of prime implicants. If let us say I have been able to combine some of these implicants to form here, then these would have got eliminated. Those implicants which have been used for generating another level of implicant, that would have got eliminated, because these will be covered by this particular implicant, and that will be prime, and these will no longer be prime. So at any stage that is applicable. So now let us look at these. Among these prime implicants, I will classify prime implicants to be of two types, essential and non-essential. Essential prime implicants are those, if you consider some rows, there is only one tick. If I consider this, there is only one tick over here. If I consider this, there is only one tick over here. Similarly, if I consider this, there is only one tick over here. But there are some rows, there are more than one tick, like here there are 2, here there are 3, and so on and so forth. Any row in which there is only one tick, the corresponding prime implicant is an essential prime implicant, and I have to include it in my function. The implication is, because this has only one tick, I have to include this. I have to include this term 0,8, it's an essential prime implicant. Similarly, because there is only one tick over here, I have to include 6-7. There is only one tick over here, I have to include this. 30-31, so I have to include this. So these are 1, 2, 3, 4, these are my essential prime implicants. So any function that I will have, I have to include these 4. Okay. So now I can draw what is called a reduced cover table. What will happen is, in my reduced cover table, I don't have to bother about the minterms which are covered by not just the minterms which have made them essential, but even the other minterms which are covered by them. Because after all, I have already covered those minterms, and I don't really have to bother about those minterms. So I will draw another cover table. Now this particular cover table will have fewer columns and rows. I will now draw only non-essential ones. There are 4 of them are essential, and these 5 are non-essential. And I will also eliminate those minterms which have already been covered by those essential ones. So if you now look at this particular 0,8 covers this, and it also covers this. 6-7 covers this and this. 20-22 covers this and this. 30-31 covers this and this. So only thing that is left uncovered is 24 and 26. So only these two rows are required. So I can draw this anywhere 24 and 26. I don't have to bother. And now let us look at so this is now the reduced cover table. So it's obvious, the choice now is obvious that in this process what had happened is among this 24 was so I will use this 24, yes. Okay, 26, yes, I'm sorry. So now if you look at this, now the problem is quite simplified. Of course in this case visually we can see that 24-26 is cheaper to use 24-26 this particular minterm this particular implicant rather than otherwise I have to take both of them. So in this case I can just choose this. Of course in a very complex situation it's not, this choice may not be so obvious. There could be, you would have to do some minimization to find out which of the subsets have to be chosen. Sometimes what can happen is in this process you can now again land up with a situation that something else becomes essential. So you can repeat it, okay, because you have eliminated some rows and you have eliminated some columns and situation has changed. But in this case for including 24 either you can choose this or this. For including 26 you can either choose this or this. So we can actually formulate the minimization problem in this case. There is a certain cost associated with this. What is the cost associated with this? With each of the prime implicants there is a cost. The cost is actually the number of literals that are present. Cost of all minterms is 5. The cost of this minterm is 4. Actually the cost of each one of these minterms in this case happens to be 4. But they can be different if you have had other stages where you have eliminated 2 literals or 3 literals and so on, then the cost could be different. In this case the cost of all of them is 4. So now to include 24, so now I call these implicants in some prime implicants, let us say I call it P1, P2, P3, P4, P5. Cost 4, cost is the number of literals present in the, so if it is 824, what is 824? 824 is 00100 and sorry 01000 and 24 is 11000. So after 824 is going to be nothing but dash 10 and 000. So now what is the expression that will realize this? This is B C complement D complement E complement. A is eliminated, B C complement D complement E complement. This is the expression and cost of this expression is 4 because number of literals are 4. And this cost is very clearly is just by the fact that how many terms are present over here. If it's a minterm the cost is 5. If only 2 of the minterms are present the cost is 4. If 4 of the minterms are present the cost is 3 and so on and so forth. If 8 of the minterms are present then the cost is 2. The cost of the prime implicant is depending on. Now what happens? To include 24 I have to have either P1 or P3. And to include 26 I have to have either P3 or P5. If I say in my final expression if P1 is present and what is the cost that I have to minimize? Cost of each one of them. So what I am saying is, if prime implicant P1 is present in my final solution, then P1 is 1. If it is absent, it is 0. Okay. If my prime implicant, so I have 5 implicants over here, 1, 2, 3, 4, 5, all of them of course prime implicants, I have 5 of them. None of them is essential. Essential ones I have already eliminated. These are all non-essential, and I had to choose a subset of them. So choosing a subset of them is nothing but solving this equation. Any solution of this, this is a P1, P2, P3, P4, P5, you can consider them to be Boolean variables. Pi, if it is present, then that particular variable is 1. If it is absent, it is 0. The expression can be formed by considering each row. In each row, at least anything that covers it. So 24 is covered by P1 and P3. Because I had to cover each of the minterms, so I can write my expression in this form, P1 plus P3. Either P1 has to be present or P3 has to be present. When I consider 26, 26 is covered by both P3 and P5. So either P3 has to be present or P5 has to be present. Of course, I need both of them. So if I now expand this expression, what is the expression I get? P1, P3 plus P3 plus P1, P5 plus I have to minimize this. I have to choose one of these because this is all OR. So, because this expression has to evaluate to true. Okay, that is the condition that I have. And for this expression to evaluate to true, I can have P1 is equal to 1 and P3 is equal to 1. P3 is equal to 1. P1 is equal to 1 and P5 is equal to 1. Of course, this will get eliminated because P3 is 1 plus P5. So this will get eliminated and this will get eliminated. If I simplify this expression, I can take P3 to be common and 1 plus P1 and P1 get. So the expression that I have is P3, P1, P5. So basically I have two options. P3 is 1 or P1 and P5 are 1. And these are the two options that I have to solve. And if I take each of the options, if I take P3 to be 1 and I evaluate this cost, what is the cost? 4. If I take both P1 and P5 to be 1 and I evaluate the cost? 8. So obviously P3 to be 1 is the minimal solution. This of course I can see it over here in this particular problem, but if we have a complex cover table, so what we are seeing is this cover table can also be solved by actually formulating a Boolean equation. This Boolean equation has nothing to do with the original Boolean equation we were trying to simplify. Okay. This comes after eliminating the essential prime implicants. I have a cover table which does not contain the essential prime implicants, but I have my minterms which are uncovered by the essential prime implicants. And then I perform this particular minimization and I get a final solution, and in this case the solution that I get is the cost is. So let's define what essential prime implicants are. So this is a formal definition. Essential prime implicants are those which cover minterms not covered by any other prime implicant. Any minimal function have to include the essential prime implicants. The reason is very clear. We cannot include the minterms themselves. We have to, because prime implicants are cheaper than minterms, and essential prime implicants are required for covering those minterms which are covered only by that essential prime implicant. So I have to have in my solution essential prime implicants. And non-essential prime implicants, of course, I have to have this strategy to actually select them. So now let us go through the steps that were involved in this Quine-McCluskey method. So this is the process we followed. We order minterms by number of ones. That is the first thing that we do. And what is the meaning of number of ones? Binary expansion of the integer value. So I take the binary expansion of the integer value, count the number of ones and order the minterms. Generate implicants by repeated combination of minterms and implicants. So I combine this. First I generate implicants by combination of minterms, and then I can, if possible, combine those implicants to get further implicants. Then I identify prime implicants. What are those prime implicants? Basically I keep on eliminating minterms and implicants which are covered by other implicants. Then I prepare a cover table. My first cover table that I prepare consists of all minterms being the rows and all prime implicants being the columns. So this is minterms being the rows and prime implicants being the columns. That's the first thing. This is the cover table. And once I have made this cover table, I look at each of the rows and try to see whether a particular row is covered by more than one implicant, or more than one prime implicant. Of course, now I have only prime implicants. If it is covered by more than one prime implicant, then that particular minterm does not generate any essential prime implicant. But if a minterm is covered only by one prime implicant, then I declare that prime implicant to be an essential prime implicant. So I identify essential prime implicants, and once I have my essential prime implicants, I perform a reduction of the cover table. What is the process of reduction of the cover table? I remove all the columns which correspond to the essential prime implicants and all the rows which are covered by the essential prime implicants. So now I have, so this includes not only those minterms, this also may include other minterms which are covered by more than one prime implicant, but because this is covered by an essential prime implicant, I don't have to bother about them. And once I have done this, I have a reduced cover table. Among the reduced cover table, I again try to identify a set of prime implicants which will cover all the remaining minterms. Once I have done it, I have now a set of prime implicants which covers the function. And now I have to express the function as a sum of selected PIs. In the previous case, I should do that process. I identified. So if I consider this, remember I had this 0, 8, let me write here 6, 7, 20, 22, 30, 31. These were the essential prime implicants. Then we also identified 24, 26. So now I can write my function. My function f is going to be so here if you see this, it is A complement, B is going to get eliminated, C complement, D complement, E complement. This is this term. This is dash, sorry, 0 dash 0 0 0. If you look at this, this is 0 0 1 1 dash, and so that's going to be A complement, B complement, C D. This is the second term. Third term is 20 22. So 16. This is, if I have a 0 here it will be 20, if I have 1 here it will be 22, so that is going to be A, B complement, C, E complement. 30, 31, A, B, C, D. 24, 26, so this variable will be eliminated, it's A, B, C complement, E complement. 24, 26 was the one that was chosen in this process. I had to cover 24, 26. I can cover by using both P1 and P5 or just by using P3. And this is the expression that I formed and chose the one which is the lower cost, which is the P3 is the lower cost one. And so that will be the minimal expression. And now so what we have done is, this is the last stage. The step. So now I express the function as a set of prime implicants that have been chosen. Can we apply this method when we have don't care? Actually, it's quite simple to apply the same method when I have don't care. I have two processes here. One is generation of the prime implicants, and then identification of the prime implicants, the subset of the prime implicants to cover the function. When I have incompletely specified functions, when I have don't care to the input, what I do is I use the don't care minterms for generation of the implicants. When I am doing the implicants, when I am listing the initially classifying the minterms into categories which are number of ones and so on and so forth, I consider the don't care terms as if they are the minterms that are present. So what it will allow me is, it will allow me to generate better, or let's say cheaper implicants, because it will allow me to combine various minterms effectively. The don't cares will be treated like ones. But when it comes to a second stage of covering, I don't include these don't care terms. The reason is I really don't have to cover them. If they have been useful in generating prime implicants which are cheaper, is good, because basically what I have done is they have helped me to eliminate some variables, but I am not required really to cover them. So generation of the prime implicants, I include the don't care minterms just like any other minterms, the specified ones. But in the second stage, when I am doing the covering process, I completely ignore them. I don't write the rows corresponding to them. If they get covered, it's fine. If they don't get covered, I don't care, because I anyway don't have to generate ones for them. So in this manner of splitting it into two stages, I can easily take care of the don't care minterms. And intuitively, of course, it's very easy to see that this will generate me the minimal cost solution, because when they are useful in, so those prime implicants which are only covering don't care terms will not really get included, because only those which are actually effectively also using the other minterms, which are specified minterms, they will only get included in the final analysis. So in this process, I can use the same Quine-McCluskey method for incompletely specified functions. Okay, with that we complete this lecture.